everyone, this is Neha. I welcome you all to ANSquare-academy. Today we are going to derive equations of motion in a very easy way. First equation is V equal to U plus AT. Second equation of motion is S equal to UT plus half AT square. Third equation of motion is 2AS V square 2AS equal to V square minus U square. We are going to derive these three equations of motion. This topic is most important topic of the chapter motion. Most of the numericals are based on these equations and direct derivations of these equations also come in exams. So let's start. Object is moving with initial velocity u, acceleration is a, and when speed increases, final velocity becomes v. Time taken to attain this final velocity v is, let's say, t, and displacement covered is, let's say, s. When an object moves in a straight line with uniform acceleration a, it is possible to relate velocities, acceleration, time, and displacement covered by a set of equations. These equations are known as equations of motion. Notations must be clear. U is for initial velocity, V is for final velocity, A is for acceleration, T is for time here, and S is for displacement. These notations must be clear. We will be using these notations directly. By definition of acceleration is V minus U by T, that is final velocity minus initial velocity by time. It can also be written as change in velocity upon time. Terms, take this t here, at equals to v minus u. Bring this u here, at plus u equals to v, and this is nothing but our first equation of motion, v equal to u plus at. Here we have got our first equation of motion. What we have done? We have taken object moving with initial velocity u, accelerated by a, final velocity is v, time taken is t to cover this distance, and displacement is s. By definition of acceleration, what we have the formula for acceleration? Acceleration is equals to v minus u by t, that is nothing but change in velocity upon time taken. Here we have taken this t in the numerator with a, at equals to v minus u. This negative u here, you bring it on the left side, it becomes at plus u. And here we have got our equation, first equation of motion, v equal to u plus at, hence proved. Have you understood this? We have got our first equation of motion so easily, just in 2 steps. We have written the formula for acceleration and we have directly obtained first equation of motion. For equation number 2 and 3, first write the definition of velocity. By definition of velocity, we have equal to upon time. This can also be written as velocity equal to s upon t. S is displacement and time is represented by t. Now the question arises, what velocity we are going to take here? Since the velocity is changing, initially it was u and it is changing to v. Velocity is not constant, it is changing. So here we will take average velocity. How we calculate average velocity? We add both the velocities. We add all the velocities, as many number of velocities are there, and divide by the number of velocities. Here we have 2 velocities, that is u and v. So we will take average of these two, u plus v upon 2. That is also the arithmetic mean of velocities. How we calculate arithmetic mean? We simply add the quantities and divide it by the number of quantities. So average velocity here is u plus v by 2. Instead of velocity, we are taking here average of velocities. Velocity is u plus v by 2, that is equal to s upon t. It implies value of s here is take this t here, u plus v by 2 into t. Just rearranging the terms. Now, this point is very important. From this point, we are going to have our equation number 2 and 3 both. Just remember this, we will get both equation number 2 and 3. Once we will put value of v and once we will put value of t in this equation, and we will get our 2 and 3 equations. S equal to u plus v by 2 multiplied by t. In this equation, let's substitute the value of v first. V equal to u plus at. In the equation number 1, what we have got? We have got v equal to u plus at. We have substituted value of v here. Now it becomes 2u plus at upon 2 multiplied by t. Take this t inside, 2ut plus at square, and also split this denominator upon this also, 2 right upon this also. 2 cancel out, this becomes ut plus half at square. S equal to ut plus half at square. This is our equation number 2. What we have done in the equation number 2, average velocity is u plus v by 2. This is equal to s upon t, that is displacement upon time. S, just rearranging the terms, we have got s equal to u plus v upon 2 multiplied by t. Here, after this step, we have substituted value of v in this equation. V equal to u plus at. Just put v, value of v here, 2u plus at upon 2. Just do the splitting of denominators, 2 upon this, 2 upon this. This is ut plus half at square now. This is our equation number 2. For equation number 3, by definition of acceleration, a equals to v minus u by t, t equal to v minus u upon a. Substitute this value of t here. S equal to u plus v by 2. Value of t in this expression is v minus u upon a. Take this 2a here with s, 2as, and this is a plus b, a minus b in the numerator, that is v square minus u square, because the formula for a plus b into a minus b is a square minus b square, and this is our equation number 3. See what we have done, we have got this expression earlier. Here in this expression we have just substituted value of t, a equal to v minus u by t, t equals to v minus u by a, and just put this value here at the place of t. Here in the numerator this is a plus b, a minus b, that is equal to a square minus b square. Carry this 2a in the numerator with s. 2as equal to v square minus u square. This is your equation number 3. Let's quickly revise equations 2 and 3. By definition of velocity, velocity is displacement upon time. Displacement is s, time is t. Average velocity is arithmetic mean of velocities. Here we are taking u and v, so our average velocity is u plus v upon 2 equal to s upon t. From here we have got value of s equal to u plus v by 2 into t. Now, this is the expression which we are going to use for equation number 2 and 3. In this equation, we are going to put value of v. V is u plus at, as we have already obtained in equation number 2. S equal to u plus u is 2u plus at upon 2 into t. Take this t inside, multiply with both these terms, 2ut plus at square, and split the denominator upon this and this. 2 cancel out, and we are getting the equation number 2 as s equal to ut plus half at square. This is our equation number 2. And for equation number 3, this part is going to remain same, and we have written this expression here. In this expression, says a equal to v minus u by t. This is the definition of acceleration, final minus initial upon time taken. From here take out the value of t. T is v minus u by a. Substitute this value of t here in this expression. what we will get? S equal to u plus v by 2 into the value of t here. In numerator we have a plus b into a minus b, that is a square minus b square. Take this 2a here in multiplication with s. 2as equal to v square minus u square. Finally, this is our equation number 3. So dear students, I hope you have understood how to derive the equations of motion quickly and easily. In our next class, we are going to derive these equations graphically. So keep watching ANSquare Academy. Thank you.